When we talk about all matter, matter can be divided into 4 major categories. The first category, the elements. The elements are substances made of one type of atom. And these are the basic building blocks of all other forms of matter. You can find a listing of the elements on your periodic table. The periodic table has a listing of about 100 plus elements, about 92 of them which occur naturally. The rest are actually synthesized in laboratories. Now, in the periodic table, you will see the symbols for the elements as well as the name. There's some other information in the periodic table, but we'll come back to that a little bit later. So a symbol for an element is either 1 or 2 letters. If it's 2 letters, then the first is always uppercase. Okay, and if there are 2 letters, then the second one will be a lowercase element. Second type of matter are called compounds. Compounds are formed of 2 or more elements joined with a chemical bond. Okay. These can only be broken apart with energy, usually in the form of heat or electricity. Or through chemical reactions. Now, the elements and the compounds together are called pure substances, which means they're made out of only one type of thing. So even though a compound is made of 2 or more elements, since they're joined together in a chemical bond, they form one single particle together. Now, elements are pretty easy to identify out of a group because you simply can find them on the periodic table. So it's worth your while to spend a little time looking over the elements on the periodic table and getting familiar with the names. Some of them would be very familiar to you, like iron and calcium and oxygen and nitrogen, and some of them will be a little unfamiliar, like neodymium and molybdenum and strontium. So those are ones that are new. You'll have to get familiar with them in this class. So spend a little time looking at the names of the elements on your periodic table. Now, compounds can be a little bit more challenging to identify. Okay, the first thing is that compounds usually have, but not always, 2-word names. If they have 2 words names, one is an element right off the table. The second looks similar to an element, but is not on the table exactly. Let's look at a couple of examples of that. So here's a very common and familiar compound, sodium chloride. This is what we call table salt. This is the chemical formula for it. It is a compound. It's made of sodium and a chlorine. Those are the two elements. Now if you look right here, this says chloride. On the periodic table you see chlorine. You see sodium written exactly like this on the periodic table. But you do not see the word chloride on the periodic table. You see the word chlorine. And we will come back and talk in a little while about why the name is changed and it's not exactly like it is on the periodic table a little bit later. But for now, if you see a two-word name, okay, and the second one looks sort of like an element in the periodic table but isn't exactly spelled the same or looks a little bit different, it's probably a compound. Other common compounds you may see are acids, okay, like hydrochloric acid or sulfuric acid. The tricky ones are the common named. These are single word names that are used commonly for compounds, usually because they're what we call organic compounds, meaning they are very complicated. They may contain several different elements and many, many atoms of those elements and very large and complex particles. So something like caffeine. Caffeine is a common name. The chemical name for caffeine is pretty long and complex, has a bunch of numbers stuck in it because it tells something about the structure and how the elements are actually bonded together. Styrofoam. I didn't spell that right. Styrofoam is basically air bubbled through a compound called polystyrene. That's the common name. But it's just one particle. It's a compound. It's a chemical compound. So watch for those. All right, our next major group for things that are not pure. They're not pure. It means they're mixtures. So mixtures are made of two or more, in some cases a lot more, different pure substances mixed up together. Okay, they are not chemically bonded. Okay, which means they can be separated by physical means. So an example of a mixture is if I took a giant dumpster and I threw in 500 basketballs, 500 tennis balls, 500 golf balls, okay, and then I just stirred them all up. That's a mixture of different balls. Now they're not bonded together, okay, and I could pick them back out, separate them back out to the three types of balls. And we will actually talk about separating mixtures in our next video. Now, we put mixtures into two categories based on what they look like. The first category is called homogeneous or homogeneous. Okay? These are mixtures that look like pure substances. In other words, when you look at the mixture, it just looks like it's made up of one thing. Okay? Another word for a homogeneous mixture is a solution. Metal mixtures, metal homogeneous mixtures, are called alloys. So for homogeneous mixture, you cannot see any of the parts or ingredients, even under a microscope. The other type of mixture is called heterogeneous, or also pronounced heterogeneous. These are mixtures that are uneven, right? And you can see one or more of the parts separate from the rest. Okay, let's look at a couple of examples of these. Okay. These are homogeneous mixtures over here. Here's some heterogeneous mixtures over here. Now, most things that we encounter in our everyday life, food, cleaning products, hygiene, cosmetics, most of these things are mixtures. Most of the things we run into our life are mixtures. We do occasionally encounter some elements. Say, for example, if you have, uh, you have like a, if you have like a magnet, most magnets are made of some type of a pure metal that's magnetic. But just about everything else is a mixture. Even like, you pick up like if you have like gold jewelry, you say, well, this is pure gold. Now, it's not pure gold because that wouldn't make very good jewelry because that would like bend and dent and break really easily. It's usually an alloy. It's gold plus something. Other metals are worth a little less but make it stronger. Put together. So just about everything else that we encounter tends to be mixtures. Now we do run across some compounds, but they're pretty rare. If you have table salt, then yeah, that's a compound. Or baking soda, yeah, that's a compound. But most everything else, we eat baking soda by itself, we mix it up together to make cakes and cookies. All right, so some examples of homogeneous mixtures. For example, if you have hand lotion, okay, or maybe shampoo, okay, or like chapstick. Okay, those are some ideas. If you look at them, you look at hand lotion, it has ingredients. Okay, that's usually a clue if you're trying to look at it. Okay, there's still an ingredient list. That's a help. So you look at it, you say, wait a second, there's a bunch of different things mixed up together to make this substance, but I can't tell them apart from each other. It just looks like, some sort of white stuff. And then that's a homogeneous mixture. Some examples of heterogeneous mixtures are a lot of our food things, like, pizza, and it's mixed up, it's one thing, okay? But it looks like you can tell all the different things apart. A salad, like a piece of granite. Granite, if you pick it up, that's like the speckly rock. It's different colors all speckled through it. You can see, okay, there must be different things to make the different colors, and I can see them apart from each other. Okay, so your challenge will be to look at a bunch of mixtures. You're going to actually physically look at, well, not just all mixtures, you're going to look at a bunch of substances that are all mixed up together. And you're going to have to determine if they're elements, compounds, homogeneous mixtures, or heterogeneous mixtures. You're going to do a little bit of this practice on paper, and then you'll also do some practice by actually looking at the actual substance.